Hello and welcome to this 14th Algorithm Selection and Development lecture in this course Master in Artificial Intelligence. So in this lecture we will talk about how to monitor and analyze model performance and validation metrics after having selected, trained and developed appropriate algorithms. So this is the last step of the iterative development and optimization process of in iterative development. This is the last step of monitoring and analyzing model training and validation metrics. So how to monitor and analyze the model training and diagnose issues and make adjustments accordingly. So how to do that? How to monitor and analyze the model training matrices to diagnose issues and make adjustments accordingly. See, what you need to do is first need to recognize that this is an important step of diagnosing issues and making adjustments that can make improvements in your performance of the algorithm. Now, what are the various steps you can take? Let's take a look at them and how to effectively monitor and analyze these metrics. First, obviously, is to select the relevant matrices. So choose appropriate metrics to monitor the performance of your model right through training and validation. The common metrics for classification tasks include, like we talked about, accuracy, precision, recall, F1 scope, and area under the ROC curve. For regression tasks, the metrics may include mean squared error, MSE, root mean squared, RMSE, or mean absolute error, MAE, or R2 R square score, right? So these are so among these you need to pick the relevant metrics for you to evaluate. Then what you do is you visualize these metrics over a period of time by plotting in the training and validation data metrics as a function of training epochs or iterations. So you then kind of see how has these metrics worked out visually over these iterations. There you can use line plots, bar plots, scatter plots to visualize how the metrics change over a period of time. So visualization is critical here. Now, when you, after having plotted them, you look for the trends, patterns, or irregularities in the plots that may indicate issues or opportunities for improvement. Then what you do is you monitor the gaps between the training and validation metrics to detect signs of overfitting or underfitting, identify such patterns. If the training error is significantly lower than the validation error, the model may be overfitting the training data. Conversely, if both training and validation errors are high, the model may be underfitting and failing to capture the underlying patterns of the data. Then you analyze the effect of hyperparameters on model's performance by varying one parameter at a time while keeping others fixed, and experiment with different hyperparameter values and observe how they impact the training and validation matrices. So you adjust the hyperparameters. Use techniques like grid search, random search, Bayesian optimization to systematically search the hyperparameter space as we had explained earlier and find optimal configuration. Then you check for the signs of the convergence issues. Detect the convergence issues such as slow convergence, oscillation, or plateauing in the training and validation metrics. Adjust the learning rates, batch size, or other optimization parameters to improve convergence and accelerate training. Then you perform the error analysis by analyzing individual instances where the model makes error or prediction with high or makes prediction with high uncertainty. Examine misclassified samples, outliers, or instances with high prediction errors to identify patterns or common characteristics. Here you can use techniques like confusion matrix, precision recall curves, or residual plots to gain insights into model's behavior and potential sources of the error. Then make adjustments to the model architecture. pre-processing steps, or optimization strategies based on the analysis of training and validation metrics. Iterate through the model development process, making incremental changes and observing their effect on the performance. Experiment with alternative approaches, algorithms, or hyperparameter configurations to explore different solutions and find the best performing model. Keep track of the performance of different model iterations and experiments to monitor progress over a period of time. Maintain a record of hyperparameters, training validation matrices, and address any adjustment made during the model development process till the time you find the optimal value. So by actively monitoring and analyzing the training and validation metrics, you can diagnose issues, make informed adjustments, and iteratively improve the performance of your machine learning model. This iterative process of experimentation, analysis, and adjustment is important and essential for achieving optimal results and developing robust models that generalize well on the new data, because that is the purpose of the model, to make reasonable and well defined with less uncertainty the predictions on the new data. So with this monitoring, understanding how to monitor and analyze model performance, we have completed the iterative development and optimization sub-step of this section. So what do we do next? Now we are now ready to go to the next step of researching, selecting the model, of considering interpretability and explainability for applications requiring transparencies and trustworthiness. So thank you so much for watching this 14th Algorithm Selection and Development lecture in this course, Mastering Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question, and also download the PDF file to take a look at anything that is of specific interest to you.